Alright guys, welcome back, and we are doing 9.4, which are exponential equations. Exponential equations. So with an exponential equation, we know we are going to be trying to solve with the exponents. And we will be changing forms between exponential form and logarithmic form, depending on what the problem is asking for. So if we're going to be kind of using our duh property, so an exponential equation is just an equation containing one or more expressions that have a variable as an exponent. So strategy number one. Strategy one is change the powers to the same base. And a quick refresher of our duh property, if we have a raised to m equals a raised to n, the a's are the same, so we cancel those out and we get m is equal to n. Also, and this is only when you have two logs equaling each other, if you have log base b of m equals log base b of n, the two logs have the same base, they can cancel out, so we get m is equal to n. And that's only when two logs are equaling each other. So we have to have the same base. So if I look at example number 1, I have 2 raised to the power of x equals 32. So what that means is I have to get this 32 to be a base of 2. So I'm going to go handy dandy factor tree, 32. I'm going to keep breaking it down with 2's. 2 and 16, 2 and 8, 2 and 4, and then 2 and 2. I got 1, 2, 3, 4, 5. So I can rewrite 32 as 2 raised to the 5th power. So now if I look, I have the same base of 2 and 2, so we can cancel those out, and we just get x is equal to 5. So example number 2 in the notes is 8 raised to the power of x equals 2 raised to the power of x plus 6. We have to see, hey, which base is smaller, the 2 or the 8? Well, the 2. So that means I want to get this 8 to be a power base of 2. So I'm going to go 8 and I want 2, so 2, 4, 2 and 2. So I got 1, 2, 3 2's. So I can rewrite 8 as 2 to the 3rd power, but I still have this x here, so I'm going to put times x equals 2 times x plus 6. Well, if I look at the base, 2 and 2 cancel out, and we get 3x equals x plus 6. And this is a super easy equation that I know we know how to solve. Move the x over, we get 2x is equal to 6. Divide both sides by 2, x is equal to 3. So that is it for strategy 1. It's very similar to what we did previously. So strategy number 2 is we're going to change into log form. Or logarithmic form. Change to the log form. So if I look at my third example, I got 5 raised to the power of x plus 5 is equal to 60. Well, the first thing I want to do is I want to subtract this 5. Raised to the power of x is equal to 55. Okay, so let's just try from strategy 1 and see why this won't work. If I try to break this down, this 55 and 5s, I get 5 and 11. Well, that's not going to work because I can't break down this 11. I can't say this is 5 to the third power or 11 to the third power. It wouldn't work out that way. So when strategy 1 doesn't work, we got to resort to strategy number 2. Which is change this into log form. So if we remember, I'm going to write this over here. B raised to x equals a. We can switch that and say, hey, that is log base b of a is equal to x. So I'm going to rewrite this as saying log base 5 of 55 is equal to x. And I'm going to introduce a new formula. And this is really important. It is called the change of base formula. Change of base, which is, if I have log base b of a, I can rewrite that and say log of my big number a divided by log of my base b. And we're going to have to use our calculators for this. So I'm going to rewrite this as log 55 divided by log 5 is equal to x. And please don't try to say, hey, this is log 11. We're not doing that. What I'm going to do, calculator. Our log button right here. So log 55, close your parenthesis, divided by log 5, close that parenthesis, press enter, and we're just going to round. You're going to get a decimal, and that's fine. Let's round 2 decimal places. X equals 2.49 as your answer. Like I said earlier, do not say, hey, 55 divided by 5 is 11. If you put log 11 in your calculator, you wind up getting 1.04, which is not 2.49. So please put it in your calculator just like this. Please make sure that you're closing your parentheses. Parentheses are important. Alright. Number 4. This is the last one we're doing today. Example number 4. I got 5 raised to the power of x minus 2 equals 200. So, right away, if you want to just take a look and see, hey, can I break 200 down with 5s? Well, 200 divided by 5 is 40, 45, and then 5 and 8, and it's not going to work out. We're not going to get perfect things. So that's where we're going to have to use our second strategy, where we're going to have to turn into a log form and use our change of base. So if I turn this to logarithmic form, I get log base 5 of 200 equals x minus 2. I'm going to change this into the change of base formula. So I get log 200 over log 5 is equal to x minus 2. So if I go into my calculator and do log 200, close my parenthesis, divided by log 5, close that parenthesis, I get 3.29. So this log 200 divided by log 5 gives us 3.29. So we have 3.29 equals x minus 2. Well, this just becomes an easier problem we can solve. If we add 2 to both sides and get x by itself. So we can say that 5.29 is equal to x. And we're good. That is it for today's lesson. Please let me know if you have any questions.